Very good morning to all. In our last lecture, we have started the last point of this chapter, modes of control. Okay. In that, modes of control, on-off controller, proportional controller, integer controller, and derivative controller. These parts are covered, and proportional plus integral parts are also covered. Only proportional plus derivative and proportional plus integral plus derivative means PID controller. Only 2 points are remaining in this chapter. Okay. Before starting this proportional plus derivative controller, within 5 to 10 minutes, revise all these points. First one is the on-off controller. Okay. This is the simplest form of controller. Okay. Means it control only two position. One is the on and second is the off. Okay. So this is cheapest type of controller and used limitations are within the tolerance. Then second one is a proportional controller. Okay. So proportional controller is depend on the percentage of this error occurred in this controller. Means the output of controller is simply proportional to the error E of t. This is called as proportional controller. I repeat, the output of controller is simply proportional to the error E of t. Okay. So the relationship between error E of t and controller output P is defined or determined by constant called as proportional gain constant known as Kp. Proportional gain constant denoted as Kp. Okay. See the output P of t is equal to K of p into E of t म्हणजे proportional constant into error plus input. See the feedback diagram. Plus R minus B means summation point or summing point R minus B. Here controller Kp and their plant, and here output will be there. Okay. So Kp means proportional gain constant and P0 is a controller output with zero error. Here control output with zero error. Then next one is the integer controller. Okay. So integer controller is based on the rate of change of its error or actuating error. Mathematically, dpt divided by dt is equal to ki, where ki is a constant relating to the integration. Ki means constant of integer. Okay. For example, mathematical equation obtain capital P is equal to ki integration of e of t error dt plus po means control output at t is equal to 0. So this diagram error first graph will display the error and second is the control output. Then third one is the derivative controller. Okay. So derivative controller depend on the time and rate of change of actual error. Okay. So it is also called as rate action mode or anticipatory action mode. And mathematically expression kd means derivative gain constant, ki means integral gain constant, and kp means proportional gain constant. Okay. So p of t is equal to kd into d by dt et plus p of o. So this expression indicate how much percentage the control output must change for every percentage per second rate of error. So generally KD is expressed in minutes. KD generally KD is expressed in minutes. These are the two graphs of error versus time and control output versus time. The next one is a proportional plus integer type controller. Okay. So this is the output of proportional integer. And this is the output of integer controller. So combination of proportional plus integral output is equal to Kp. Okay? Kp means gain constant of proportional into Et error plus Ki gain constant of integration of E of t error dt. This is the combination of proportional plus integer type controller. Okay. So the important advantages is that one to one corresponds of P mode is available. That is I mode. The integer part of such composite control provides a reset of zero error output after a load change occurrence. Here two graphs will be there, error versus time and output versus time. So integer time will be the changes T1 to T2. Then Vi means rise in output due to the integer action between T1 and T2, and Vp is immediate rise due to proportional action. Okay, it's Vp is immediate rise due to the proportional action. Vi means this is the difference between time T1 to T1 and T2. So I think this part is remaining. Okay. So under the heading proportional plus integer type controller, under the heading proportional, or give the write down the proportional plus integer type controller in bracket pi controller, and draw these two graphs and write down these two sentences. Give the heading proportional plus integer controller and draw these two graphs and give the heading, and also write down these two sentences vi and vp. Also write down these two sentences. Vi means here rise in output due to the integer action between times T1 and T2. And Vp means immediate rise. Here immediate rise due to the proportional action. Okay. Then draw these two graphs, error versus time and control output versus integer action. Draw these two graphs, error versus time and control output versus time. Here PT versus time and here error versus time. This is composite mode and this is proportional mode and this is integer mode. Here this is integer mode, this is proportional action, this is integer action, and in between proportional and integer, in between composite mode will be there. Okay, so draw these two graphs. In first graph, error versus time. So only proportional or proportional plus integer, the line display in the straight line. And control output versus time graph. Proportional action is in the straight line, but in integer action, give the inclined motion. In between, composite mode will be there. Means composite means combination of proportional action plus integral action. Okay. Then write down the controller output changes linearly with respect to time at a rate constant or proportional into time. The reset rate is defined as the reciprocal of time. Okay, means Kp divided by Ti means the reset, the reciprocal of this time. The response shown in figure for the direct action of the controller, response of composite PI control mode for reverse action as shown in figure B. The sum of PI action finally leaves the error equal 0. Okay. Then next point is a proportional plus derivative controller. Okay. Write down the heading proportional plus derivative controller. P plus D controller. Proportional plus derivative controller. P plus D controller. Proportional plus derivative controller. P plus D controller. Here output of the proportional controller is that Kp means constant of proportional gain into error E of t plus derivative control output is Kd d by dt E of t error plus proportional output. This is the derivative controller, and proportional plus derivative controller means output of proportional controller plus output of derivative control. Here give the description: a controller in the forward path which changes the controller output corresponding to proportional plus derivative. Proportional plus derivative of error signal is called as PD controller. Okay? Means combination of proportional plus derivative with error signal is called as PD controller. Okay, a series combination of P and D controller gives P plus D control mode. In mathematically, here the combination of two output. First one is the proportional output and second one is the derivative control output. Then the behavior of such PD control to a RAM type of input here is shown in figure. Okay. So before drawing these two graphs, write down 2-3 sentences of proportional plus derivative controller. A controller in the forward path which changes the controller output, corresponding to proportional plus derivative of error signal. Proportional plus derivative of error signal is called as PD controller. Is called as PD controller. Okay. Full stop. The next line. A series combination of P and D controllers. A series combination of P and D controllers gives P plus D control mode. In mathematical expression, output of controller PD controller is equal to P of t is equal to Kp gain constant of proportional into error E of t plus Kd gain constant of derivative controller d by dt error E of t plus proportional output. This is the mathematical expression of proportional plus derivative controller or PD controller. Then draw these two graphs. Draw it fastly. See the first graph, error versus time, and second graph is the error versus time with the two different time concentration T1 and T2. Here Vp means rise in signal due to the proportional action between time T1 and T2, and Vd means in immediate rise due to the derivative action. In last proportional plus integral controller, in that Vp or Vi is the immediate rise due to the integral action. Here Vd is the immediate rise due to the derivative action. Okay. Then write down the ramp function of errors occurs at t is equal to t1, and the derivative mode causes a step Vd at t1, and proportional mode causes a rise of Vp is equal to Vd at t2. Here t1 Vd is equal to t1 and Vp is equal to t2. Therefore Vp is equal to Vd at t2. This is for direct action of PI control. Prajakta Survey. Okay. Third year B division, roll number 80. Nityanand, what is your problem? So don't do again. Unmute yourself. Also start your camera. Nityanand ji. Okay. So draw this graph. Here the graph display error versus time. For the behavior of PD control for the arbitrary load changes of this reverse action. Okay. Then next is last point of this chapter, proportional plus derivative plus integer controller or three mode controller or PID controller. Okay. Give the heading. This is our last point of this chapter. Proportional plus derivative plus integer controller or three mode controller or proportional PID controller. Give the heading proportional plus derivative plus integer controller or three mode controller or PID controller. So in three mode controller or PID controller, it is the combination of proportional plus derivative plus integer controller. That's why it's called as three mode controller or also called as composite controller. So see the output of this control combination of three outputs means proportional output plus derivative output plus integral output. Here proportional output is Kp gain constant of proportional error into error plus Ki gain constant of integration of E of t dt plus Kd gain constant of derivative d by dt E of t error. Okay. This is the combination of three control output means proportional controller plus derivative controller plus integral controller. PID controller. This is the combination of PID controller. So total three controller, proportional, derivative, and integer. It is very useful for to error this remove the all error occur in this control action and the response is very fast due to the derivative mode. Okay. Then this is used for any process condition control action within least setting time or minimum setting time. Okay. See this graph. Before drawing this graph, write down this two, three sentence of this three mode controller. Okay. Write down the composite controller, including the composite controller, including the combination of P, I, and D control modes is called as PID control mode or three mode controller or three mode controller. Mathematically, the output of controller P of t is equal to Kp into E of t, proportional control output plus derivative control output Kd d of dt E of t plus integral control output Ki integration of E of t dt. Then write down. This mode has advantages of all the modes. First one, I mode eliminates the offset error. I means integer. I modes eliminate the offset error. P mode give response very fast, and D mode produce sudden response. Full stop and next line. Thus, it can be used for any process condition. It can be used for any process condition with the PID control action. With PID control action, there is no offset, no oscillation with least setting time. So there is improvement in both transition. So there is improvement in both transient as well as steady state response. As well as steady state response. So here draw these two graphs, error versus time and control output versus derivative action. Okay. Draw these two graphs. Here in two graphs shows the response of PID control mode for the particular signal error with this direct action. Here error versus time. This inclined line shows the PID control or action will be the decreasing side with respect to time, and control output here proportional action, derivative action and integral action. So in that Derivative action will be in a straight horizontal or vertical line, and proportional and integral action will be in inclined motion. Okay. Then draw this last graph. So here display the various control mode to unit step load changes, means load will be the changes, even load will be the changes. These three controllers, means proportional, derivative and integral, these three controllers changes their position with respect to the changing the load. Okay, so draw this graph. Okay, so see the graph, proportional output versus time. So here, so changing the load with respect to the corresponding action, this controller, individual controller, means proportional, derivative and integral, taking different action or motion. Here PID controller, this is the combination of proportional, integral, derivative controller, and here PI controller, here only PD controller, and here only proportional controller, and this line indicate the without controller. This line indicate means without controller, there is no controller, PID, no control is that, and here proportional controller, PD controller and PI controller. Okay, so this point is our last point of this chapter, and today we are completed 4 units or 4 chapters. So if you have any doubt, any question, any problem regarding this chapter or any point, so unmute yourself or text me in chat box. Otherwise, message me in my WhatsApp number if you have any doubt, any question. Okay, so these notes or PPT or PDF file provide to you in your Google Excel sheet, also in our WhatsApp group. So if you have any doubt or any question, otherwise place your roll number and leave the meeting.